Welcome to the fourth section of this course. In the previous section, we configured App Service and made our first deployment. In this section, we will dive deeper into deployments and also use web jobs. We will begin by solving some errors caused by the previous deployment. Moving on, we will set up automatic deployments using GitHub. And after that, we will also deploy using Visual Studio Team services. Setting up staging slots for testing is the next step. And once we set them up, we will push a new feature first to staging and then to production. In the last video, we will configure the cron job that archives to-dos so that it works well with Azure Web Jobs. In the previous video, we successfully deployed to production using a remote Git branch. In this video, we are going to solve some issues that we missed in the previous deployment. In this video, we will reproduce an internal server error and find out that the server stops working after such an error occurs. In order to resolve that issue, we will use NodeMon. And we will also do something that we've been putting off. We will run migrations in the production database. Let's just begin by browsing our deployed application. I'm going to click on Browse, and then I will attempt to sign up. A new user. The thing is, we haven't run migrations on the production database yet. Thus, the production database does not have a users table. Therefore, our operation will fail. But what's even more important is that if we attempt to refresh, we see that our application is no longer up. Some internal server errors, uncaught exceptions, and unhandled promise rejections may bring your server down, and this is normal for Node.js applications. In order to avoid that, we're going to install NodeMon. NodeMon is a command line tool that runs your server and restarts it if something happens and the server stops working. An alternative to NodeMon is PM2, in case you've heard that too. But we're going to go with NodeMon here. I'm going to install NodeMon as a project dependency, and then in package.json, in the npm start script, I'm going to replace the node server with a call to where the NodeMon CLI has been installed in our project. Remember, we're not using the default shortcut. We could use NodeMon space server/server, but that wouldn't work because it wouldn't be globally installed in our server machine, and that's normal again. Time to face what caused the internal server error in the first place, which is none other than the fact that we haven't run migrations in our production database. In order to do that, however, we need to be able to connect over SSL. And in order to do that, we have to copy the certificate that we can find in this URL. It's common. You use the same key for all your MySQL databases. We just download it. I've put it here into a separate file. As you can see, it's alongside my config.js file where we config Sequelize. And in here, for the production database only, you really don't need SSL when working locally. I'm going to enable SSL and also pass some options down to the MySQL library, the direct MySQL library that is being used by Sequelize. And those options are that we need to encrypt the connection and pass the certificate. In order to read the certificate, we're going to use the FS Node.js library. And one weird thing about this that you need to remember is that you need to read this in a synchronous manner. So we're going to use the read file sync method, even though it may be considered deprecated. It's always advisable when using the FS library to use the async file read method, but in this case, it's one of the very little cases that you need to use the synchronous one. Now, in our post install script, we need to run those migrations. And how do we do that? We're going to call Sequelize in our server-side post install script. And we're going to migrate by also making sure that we point out to the correct configuration file. Remember, this is going to be run from the root of our project and not through the server root. So we need to provide two paths, one to the configuration file and one to our migrations folder, which is right here. Just like that. Now we are ready to deploy this and our migrations will be run on our production database. Let us write down a commit message and then post this over to GitHub, and then later we can push it to Azure as well and initiate the deployment. I'm gonna hit the push button, wait a few seconds, and we can be certain that the commit has been pushed. Now we're ready to go back to the terminal and push to Azure to trigger a new deployment. The deployment will start and hopefully our migrations will also run, and in less than a few minutes we will be able to see our new tables in our production database. The migration has been successful, and now if we go to our production database, we can see that we have 3 tables: to-dos, users, and of course SQLized metadata, where SQLized stores stuff about migrations. Perfect. Now if we go back to our production page, we can sign up. Let's use some fake credentials. Let's say I'm John Smith with this weird email address, which I'm pretty sure is taken, and the password. Hit on sign up, and we are successfully redirected to the page, and we can add some to-dos. Perfect. You can see that if I hit enter, I got a new to-do, which means it's stored in the database. If we refresh, we can see it as well, and it can also be checked for completion.